quickly. So as you guys know, we are going through this AI revolution, and computer vision, of course, is a branch of AI. And so this is a famous quote from this famous Stanford professor: AI is new electricity. It's impacting every walk of life. It's going to impact lives and livelihoods of people. And so you've heard about this AlphaGo and all the great things Google is doing, and this Nobel Prize winner says that good AI will actually outsmart the humans. This is the Daniel Kahneman, who got the Nobel Prize in economics, and his view is the human brain makes lots of mistakes when solving problem. If you can build the AI systems, good AI system, that will be actually better. So he has written a very nice book and very easy to read called Book of Why. If you are interested in reading books, I think you should look at that. So you have heard a lot of these things about self-driving cars, especially Tesla, Musk. He's keep talking about that, and almost every Chinese company wants to do the self-driving car. Mobileye is a famous story. So Mobileye was started by a professor in Israel, Amnon Shashua. It was bought by Intel, $15.3 billion. And that's a computer vision system, they want to use. It's widely used. And then you are hearing these days about GPT. This is a language model that you prompt. It can write a poem, it can write stories, and so on. And there are, lots of talk about every day. They are in the news items, how big is a model, and so on. Of course, these models takes a lot of computing power. So this is a quote from the famous professor from Berkeley, that we have to look at the economy-aware approach to AI. And then, there are these classical approaches like a kernel-based approach. So they're talking about, if you can find some relationship to the old approach, then we can understand what deep learning is doing. Then all these startups, how much money they are raising and so on. These language model people are building, in billions of parameters they have. Then the question is, they are bigger, but actually there are lots of mistakes. They're saying the bigger liars they are, the bigger the models are. Should be worried about it. There was this article in IEEE Spectrum. There's diminishing returns, because there's the improvement is unsustainable. And so, as you have learned in 5415, that the basic thing we do in deep learning computer vision is this CNN, which we take an image and we make prediction about input image. So this is the idea here, that we want to recognize different kind of objects. So it is disruptive because I've been working in computer vision, long time, but this is the first time that we are using learning so solely to solve vision problems, and mostly supervised learning. So we need labels. But now there is a push because labels are costly. So semi-supervised learning, where we have few labels, but others unlabeled, and then weakly supervised and unsupervised, self-supervised, where we don't have to have labels. And there are all kinds of these learning method, and reinforcement learning, which is used in robotics and so on. And all of these are data driven. You need a lot of data. So that's what they are saying, that the data is new oil, and China is new Saudi Arabia. So that's a famous quote from one of the famous guy. So so this is a very different paradigm compared to what we used to do in classical computer vision. So it's a linear learning, but results are amazing. I never thought I will live to see so excellent results on some of the most difficult problem in computer vision, which is amazing. And progress is rapid. I mean, we have so many papers coming up so quickly, and computer vision is impacting other areas. The natural language understanding, robotics, computer graphics, speech recognition, because this whole, in a way, revolution started from ImageNet. Once people saw the success of ImageNet, then things completely changed. AlphaGo and all those things. So there's a dramatic increase in number of publications, as I said, attendance conferences, data set, startups. Academics are moving to industry. We are losing many professors. They are going to Facebook, Google, and Amazon, making lots of money, which is a loss. And there are a lot of software platforms and libraries, GitHub, GPUs. We never have enough GPUs. And all the online courses these days. I mean, you probably don't need to buy any book. Everything is online. You can listen to just videos, and you learn a lot. I do myself. So the conferences for computer vision, there are 3 major conferences: ICCV, which is every 2 years, CVPR, which is every year, and then ECCV, which is every 2 years, every other year ICCV, and every other year ECCV. And then journals of transaction on patterns and machine intelligence, PEMI, Intelligence Computer Vision, Journal of Computer Vision, CVIU. But these days, actually, conferences are more important than journals. We used, in the old days, we used to require each student to publish papers in journal. Before a graduate student, I want to have at least one PEMI paper. Now we are submitting papers to PEMI which are rejected from CVPR. So it's completely different. I mean, it's mind-boggling. So machine learning conference, because now there's vision and machine learning and NLP, all these are interacting and interface. So we never published conference in machine learning conference, but we are publishing now. We have actually this year NeurIPS paper. So neural information processing system, the ICML, International Conference on Machine Learning, ICLAIR, International Conference on Learning Representation. So this is the NIPS, it used to be called NIPS, but now it's called NeurIPS 2018. In 12 minutes, all the registration was finished. Okay. Now, due to COVID, there's a problem. They're not faced in-person conference. So I have these slides from last few years, but that give you an idea. They are saying that this is faster than this year's Burning Man, but it's still not as fast as Beyonce's concert. Maybe next year. Maybe if there was no COVID, maybe it will actually happen, would have happened. So this is attendance in conference. You see that 2006 we used to have 1,000. Now it's amazing how these numbers have increased. And this is the submitted papers and accepted papers in CVPR. 56% yearly growth with 26% acceleration. Okay, so that's amazing. And now, amazing thing is, this is the shocking, I mean, nobody can believe this. So CVPR is the 4th best venue to publish among all sciences. Okay, so I mean this, no, I think I need to stop sharing and then come back here. Okay, so this is the link I linked, click. So you guys see that? So this is ranking of all journals. So this all sciences, chemistry, physics, math, biology, everything. So Nature is the most prestigious journal. The New England Journal of Medicine, number 2. Science, number 3. CVPR, number 4. Which is, amazing. And then you look at, this is iClear, this is the NIPS. And this is even higher than, the National Academy of Sciences and so on. So that's where we are. And you are lucky to be in this area and taking the course. So you should be very happy about yourself. Okay, so where do we go here? Here, let's see. Okay, you can see again. So that's where we are. And then, these are the other conferences, which are computer science. If you look at the ranking, again, I have to stop here and go back. I should find out some better way to do this. Okay, so here are the all computer science conference. Again, see the CVPR is number 1, Neural NIPS is number 2, ICCV number 3, and ECCV is number 4. I mean, all these, this is what we do. So that's where we are. Okay. So let's see here. Okay. So now Hinton, who's the father of the deep learning, who got a Turing Award last week, I think last month, reached 500,000 citations. Okay, 500,000, 500,000. Then, so, and actually, let me go back. So now what started, the whole revolution started from this paper, LXNet, okay? So that has reached 100,000 citations, one paper, 100,000 citations. And then the next paper, RaisNet, 100,000 citation. As you see, this is 2016, 5 years, 100,000 citation. And this is 2012, 9 years, 100,000 citation. So this is amazing. So this is the number of publications, how they're changing, AI journals publication. This is the, hey, how do I start these pictures? Okay, now I can see, good. So you see that the US is how the US number of papers starting, and then the China is catching up and Europe is catching up, which is China is a new phenomena that, they're publishing lots of papers. Then this is the plot about how the training time has decreased, okay? From 2018 to, it was 6.2 minutes, the ImageNet training, and now 1.3 minutes, now you can do 47 seconds. Of course, the acceleration has increased, that we need to put a lot of GPUs and so on. And then, of course, there's, AI has problems. So like equity, the fairness is a big problem. So these are the results on speech recognition, speech to text. They do very well for the white people because the error is low. Same Apple, IBM, Google, Amazon, Microsoft, but black speakers, it's very high because it's not fair. They don't have the same amount of data. So that's a problem. Of course, investment in AI has been going up, as you see here, big thing. And then the PhD, the old days, once you get a PhD, you can, only job you can find is universities, academia. But now there are lots of people actually going to industry. So which is a big change. And also the ethics, because as I showed you earlier that, we have to be careful that these automatic systems, may have problems in the society. So people are starting to realize the ethical issues. And this is how number of papers are changing. And the other equity, we need the gender equity. We don't have that many female PhDs. Okay, so in general CS and AI, it's a big problem. Also, then with the different races, like white is this much here, then Asian, black, and multiracial, and so on. It's very interesting. This is the article in IEEE Spectrum, the 15 graphs you need to see to understand AI in 2021. It's a very, very nice article. I took these plots from there. Okay, so AI revolution has started, but then there are some concern, as you saw in the earlier plots. And this is a quote from researcher from Google. So machine learning has become like an alchemy, because we don't know, why is it working so well. So one problem with deep learning is that they are brittle. So if you have some small perturbation, can cause a state abort, DNA misclassified image. And also deep learning systems are black box. We don't know that why they are working. Their predictions are not explainable. So you have heard about explainable and adversarial take. So let's say we take an image here, we just add random noise, add up, and we don't see anything because it's so small. Now, this will say it's a panda, but after we add it, 99% say gibbon, completely different class. So that's a big problem. So then also same about the explainable AI. So let's say these guys build a system to recognize wolf versus husky, and it works pretty well. And there was only one mistake. But then they tried to understand, this classifier making decision based on what are the pixels being used. And so these were the pixels which are shown here, which were used. And then they found out basically it was just detecting snow to, say it is the wolf. So actually it wasn't, learning anything. So even though it was giving the results, and that was the main issue, say it was looking at the background. So that is a problem, and we are working on that. So I have these quotes from famous AI experts. So I'll go through quickly, and this is also in the spectrum. So Benjo also got the Turing Award. So what basically is saying that we have made progress, but the intelligence is nowhere close to the level of 2-year-old child. We have to do a lot more. And dig into industry, and you'll find AI changing the nature of work. And we need to think about how to steer AI. How do we transform today's buggy hackable AI system into system we can really trust and make sure they really do what we intend them to do? How do we teach machines to understand our goals, adopt our goals, and attain our goals? And this is another quote. Policy goal is to get regulation to enforce their laws in the age of algorithms. You can't give up enforcing anti-discrimination laws because you don't understand the technology. So that's a big thing. There'll be more laws because these AI systems are being used in real life and they're impacting humans. This is Jeff Hawkins. General intelligence doesn't mean you have to understand humans. There'll be a lot of intelligent machine that don't need to know that stuff. Take, for example, a robot construction workers on Mars. I don't think they need to understand human emotion and human desires to be able to construct things. This is Kai-Fei Lee. AI will take many single tasks, single domain jobs away. You can argue that humans have abilities that AI does not. We can conceptualize, strategize, create, whereas today's AI is just a really smart pattern recognizer that can take in data, optimize. But how many jobs in the world are simple repetition of tasks that can be optimized? This is Fei Li, the ImageNet inventor. The AI is fundamentally an applied technology that's going to serve our society. Humanistic AI not only raises the awareness of importance of the technology, it's a really important way to take diverse students, technologists, and innovators to participate. And this is Andrew Ning. Those of us in machine learning are really good at doing well on test set, but unfortunately, deploying a system takes more than doing well on test set. All of AI has proof of concept to production gap. Michael Jordan, while the science fiction discussion about AI and superintelligence are fun, they are a distraction. There's not enough focus on the real problem, which is building planetary scale machine learning based system that actually work, deliver value to humans, and do not simplify inequities. What is missing is principle that would allow machine learning how the world works by observing and by interaction with world. A learning predictive world model is what we are missing today. And my opinion is the biggest obstacle to significant progress in AI. Jan LeCun, the beautiful thing about AI and robotics is that you are never done. Those who argue that risk from AI is negligible have failed to explain why super intelligent AI system will necessarily remain under human control, and they have not even tried to explain why super intelligent system will never be deployed. Stuart Russell is a famous professor from Berkeley. So also there's lots of controversy, though this is Professor Schumhuber, German professor. He was inventor of the LSTM, so he always have quarrel with and those Jeff Hunton, Jan LeCun, and Benjo because they got the Turing Award. So he's saying astonishing deep learning breakthroughs. SCM gave the awards. They mention it's due to speech recognition, natural language processing, computer vision, as well powerful deep learning tools in 3 fields: medicine, astronomy, material science. Most of these breakthroughs and tools, however, were direct consequence of breakthroughs of my lab and other labs in the past decades, 3 decades. So he's always arguing. So